So Daniel, you posted a question in the chat, but we're actually going to be introducing you in just a moment, so we can actually dive into that.
Well, thank you for having me on. Yeah, I put in my 2 cents there. That IP is really easy to transport. Genetic code for plant engineering and any other code-based IP would be maybe a good economic output.
All right, so if you're not familiar with Dr. Daniel Thompkins, he has a lifelong passion in plant science and has contributed to agriculture and the natural environment with a doctorate degree in plant medicine from the University of Florida. With a diverse 20-year career from academic to industry, he founded Grow Mars in 2017, focused on methods to expand agriculture beyond Earth and how this can be done practically and sustainably with Earth-based use as well. So I'm so excited that you're on and following up with us, because we can't go to space if we can't eat. And we were just talking about fast food, but any kind of food in space is going to be vital.
Absolutely. And it's interesting because you say, oh, we can't go to space if we don't have anything to eat, food, right? And you always see air revitalization. How are we going to generate air separate from food? And that just shows the disconnect, that if you're growing your own food there, you're doing the air revitalization, as that loop is closed. So it's very interesting working in agriculture where 99% of the population, particularly in Western areas, are not engaged with agriculture. We have this luxury of going from predominantly an agriculturally based, labor-based society, and same kind of parallel with space. Is I think probably about 1% of the population is really engaged with space, and there's challenges there in communication for sure.
One of the things two of the things really that astronauts are commonly asked, especially from youth, is, what's the toilet like? How do you go to the bathroom in space? And the other one is like, what do you eat? We want to see the packets of goo, and that shouldn't be that exciting to me. Like, food should not be that exciting in space. That's another thing we should really make boring. Closed loop systems. That's really the key here, right? Food is part of this entire complex system that we're going to be involved in. You talk about Earth and space connecting with this. How can we demonstrate the closed loop systems in a way that brings value to people who don't want to leave the planet, but also those who want to go to space?
When looking at the challenges of food production in space, that carbon loop is intensive, right? So how do we do that in an energetically efficient way? Do we use just passive solar radiation? Do we use LEDs to grow high efficiency, but in a high capital way? It's big questions for how we continue to grow food on Earth. A number I often point to is actually just the nitrogen loop, which is often missed. Is that about 4 to 6% of energy used on Earth is just to fix nitrogen from the air into fertilizers, and then to off gas that again in wastewater treatment systems. And no one thinks of that as like part of their budget, or no one thinks about, the nitrogen cycle in space. So I think carbon obviously has had a lot of attention, how permanent, where is carbon used in our everyday lives? And we're figuring out more and more how relevant it is, everything from bioplastics to renewable chemicals. Kind of in a post-oil world, how do you produce all these renewable chemicals that you need for a variety of things that touch our lives? That will have to be solved for in space. And we're also trying to solve that on Earth as well. Working in both small scale and large scale agricultural systems, it's really about dirt and plastics. So one of the innovations that I was doing is having abundance of plastics and therefore kind of an abundance of food production capability in space. And it's kind of centered around the carbon loop as well.
So where do you feel we are as far as prioritizing closed loop systems and nitrogen and these other aspects you're talking about in the space industry? Like, if you had to kind of give us a report card, how are we doing at the moment?
Well, biosphere is often looked at as, a closed loop model, and a success or a failure, depending on who you talk to. We definitely learned a lot along the way. Ultimately, I consider it a failure because no one else built another one. As you see a lot of these geodesic domes, you see a lot of these biosphere inspired concepts, but they are prone to entropy, right? They take a lot of maintenance. There's construction issues, maintenance issues. No one said, "Oh, I want to build another biosphere. That's so cool. I want to do another one." So I think we need examples of how reproducible and how maintainable these systems can be, and that will be a real ticket. You see a lot of these expensive Even the kitchen garden systems are like $600, and like all of them have failed except for Miracle Grow because they like sell the fertilizers and starter plugs and stuff. So as easy as it can be to stick the seed in the ground and grow a plant, right? It gets really complex. That's kind of my day job as an agricultural scientist, is solving the plant pathology problems, so the plant diseases, the entomology, the soil and water science, all the things that go wrong in these plant-based agricultural systems. But we can get away from some of those challenges as we advance with technology. But the real trick is you got to be able to outgrow. Is you have to be able to reproduce that system and expand faster than you die, which is really the secret sauce of life, if you will. Is if you're not expanding, you're kind of by default dying.
So I give you an unlimited budget and I say, run with this thing, make it happen, secure this future for humanity. Give me maybe the first 3 steps. Like, what are you going to put all this into right away to get us started in that multi-planetary future for humanity?
So I would put it into a seed-based system. So in that regard, right, you can either send the whole plant, or you can kind of send the baby plant, where you could send the seed. That's really the same challenge that we have when we're going out into space. Is you can basically bring the food, you can bring the greenhouse, or you can bring a machine that makes greenhouses exponentially with a lot of their waste products. Because when you produce food, especially in a traditional sense, if it's not green goo, you have a lot of other biomass that actually is highly organized. That again, you can distill down into a lot of different chemicals. Pretty much all the chemicals you can make from petroleum, you can make out of raw biomass as well. So it's this huge gradient of organization and resources that you can tap into. And so the third option, bringing a piece of hardware that's relatively small, that allows you to bootstrap your production capacity of greenhouses for both orbital, lunar, and Mars. We have architectures for all 3 of them. And it looks like a really exciting system. And ultimately, it's very bio-inspired. If you think of how a plant moves around, it's not the biggest seed that wins. If you ever see like a little tiny sequoia seed, it's like the size of a pinhead. It grows into one of the largest things on Earth. Look at like a coconut. It's this giant seed with a lot of energy packed into it, but it doesn't grow as large, right? So it's really not the size of the seed. If we look at biology and how it works, it's not necessarily the size of the seed or how many there are. It's really, does it have the blueprint to succeed and to keep expanding and be persistent? And so I'm trying to make robust systems that kind of are over the horizon. I just got off the call with someone who works within controlled, basically vertical greenhouses internationally. And I said, who's on the forefront of this stuff? And, it's still, agriculture is a slow cycle. It's slower than the university cycle, unfortunately, where you have professors that turn over every 20 or 30 years. Farmers turn over like every 40 or 50 years. So it's a very slow product cycle. Almost everything we do in agriculture, basically someone was doing it 20 years earlier. So,
well, I think it's really dangerous to disrupt too. And I think that's where we find some pushback. I live in an area with lots of farmers, and they won't sell their land to anyone unless they can guarantee that person's going to carry on the crops that their family has been, taking care of for generations. It's terrifying to farmers, the idea of their land going to some use besides feeding people. And I think the general public has a concern about disrupting food supply. So I think that may be part of the reason why we get such pushback when it comes to innovating in the food cycle. As far as your work goes, what sort of like pushback have you experienced? Where is the messaging not working out? Like, how can we get this message out in a way that it will allow you to make those changes necessary for that multiplanetary future and for integrated closed loop systems on the planet?
Yeah, I think the message of being able to bootstrap them, very much how biology is very bootstrapped, is showing that from an infrastructural standpoint, is showing examples where you can start with very minimal resources, something as simple as a 3D printer and some basic distillery equipment, and actually produce a highly functional material resource to use that allows you to do things you otherwise wouldn't be able to, just with the natural environment or the economy that you're within. So hopefully we can do some demonstrations on how you can use biology to do a lot of work for you, which ultimately it will do within these systems. It will do the air revitalization, will do the cleaning of the water, the ecological services of providing ultimately clean water out the other ends of these systems. So that's why I kind of talk about agriculture in space, because it's a much bigger umbrella. It's from a material science standpoint, habitats, clothing, food, clean water. It's all of those things. It's really food production and all those ecological services that do a lot of work for us on Earth. How do we do all those in a very structured but expandable um, environment that really shows people this isn't, you look at a lot of the space art and you see a lot of hardware. You see, oh, that's another $1 billion for Lockheed Martin. Oh, that's another. It doesn't necessarily lend itself to reproducibility and sustainability. And hopefully we can, architect how some of these smart cities, these future cities, if you will, that would be an ideal project, I think. A lot of those have a lot of the same constraints, and you literally just change the background of those, and they almost look identical in aesthetics and in some of the components that they're incorporating into their design elements. So hopefully we can find some good futuristic Earth-based demonstration sites to demonstrate this, as well as use it in space.
Absolutely. I think in some ways, when you're building rockets or you're building satellites, you almost have it easier with the public, even though we've talked earlier about the hardships when it comes to communicating the importance of those things to the public. You almost have it easier because we expect a rocket to be involved in space. We expect satellites to be a space thing. And maybe it's a little bit harder when you're talking about agriculture, because some people will say, oh, well, a whole system of agriculture and chemical processing, and well, that's all kind of too far down the line. Why should we prioritize it now? But I think you've got it easier, maybe in the sense that funding is going to come much easier for your projects, because those are instantly applicable right here on Earth. Am I right?
Yes, I think some of it isn't. It's actually not that shiny of technology. It's not. It's just applied in a new way. For instance, none of this technology didn't exist in 1952. So actually, if we had pursued biological life support and we thought of that carbon loop a little bit differently before we even went to Apollo, when they were looking at using bioregenerative life support systems, which there's resilience issue. Okay, what if your algae dies? But thinking larger about staying, that's what excites me about the Artemis program, is this whole idea of, if we stay, that's a new technological barrier that we break through. We went to the moon 50 plus years ago, but if we go there to stay, that has a huge a huge technology package that will need to be developed, that will have a lot of relevance. But again, I don't think it can be a $1 trillion camping trip. It has to show people on Earth, wow, even in the extremes of the moon, with extreme limited water resources, extreme thermal conditions, they can thrive and expand. That, I think, has big geopolitical take-home messages to Earth, is saying, oh, wow, regardless of where I am in Earth and what resources I have, we can do resource creation on site. And I think that will be a big moment, however it's implemented.
Absolutely. If we look at the context of the Apollo era, DARPA and NASA arose at the same time out of the Sputnik craze and this fear that Russia was going to beat us somehow to space and have a military advantage. And so really, as great as it was, because NASA did an amazing job and the Apollo era was heroic, it really was an extension of a geopolitical will that wanted to make sure Russia didn't beat America to a strategic point. So I don't think they were really thinking about the bigger picture of a human civilization in space. It was more like, two kids fighting over something, and one of them licks it first. It's mine. You have to back off. I got there first. Now we're looking at a whole new era of real migration into space, and we're talking about civilizations, and we're talking about cities. And Elon Musk is saying things like, we're going to put 1 million people into space. Now that we have this ideal, do you feel like there is a real priority in situ and building a civilization out there that's not so dependent on coming back to Earth for supply?
Yeah, and even from a waste stream standpoint, especially on the moon, right? ISS, we down mass and burn up a lot of our waste, and we still can't do, laundry in space, right? Is one example that's often pointed out. So there's a lot of resources that we could have been using, from the waste carbon dioxide to all the other waste materials. How do we upcycle those into more infrastructure? And it's kind of exciting because it levels the playing field. Is it really doesn't matter if you have a reusable rocket or if you're using SLS or whatever. In situ resource utilization really reverses that rocket equation and ultimately accomplishes the goal, agnostic of scale, whether you're starting with a very small, mouse habitat or something like that, and you're showing that it can be renewed and expanded using resources in sight, um, it's really agnostic of scale, is what I see from the examples of biology all around me and those systems to actually accomplishing this space settlement, which we got a lot of pushback, early on. I remember going to some NASA folks early on, and they said, "We're not in the business of space colonization. That's not our gig." And the messaging there was even lost with some folks at NASA around, well, it's untethering from Earth's natural resources. It's not colonizing space. It's not settling space. It's figuring out how to live and expand independent of Earth's natural resources. Whatever name you put on it, it has big mission architecture implications, especially for Mars. I mean, you're stuck there for 2 years. You miss a flight or something like that. How small can that lifeboat be? And if you have this ability to bootstrap your way from a material standpoint out of a lot of sticky situations, I think it both within a mission can have a huge impact around survival, as well as on Earth, where people are feeling rather resource limited, I think.
Absolutely. Only 10 years ago, if you were to talk about human exploration of space, you could be barred from certain conferences. You could be kind of blacklisted and seen as, out there, outlandish. It's kind of like the alien topic. If I said I was channeling aliens 10 years ago, I might as well have said that if I was talking about human exploration of space in a big way and some of these science circles. Now we're really getting very comfortable with this idea, and it's everywhere. You're going to have to show the systems you're trying to build. And you've talked a little bit before about the hidden space program. Can you touch briefly on that before we go to questions, and kind of how you would use that to demonstrate what you can do in space?
Yeah. I think the industry and the funding mechanisms, I mean, I'm here in Washington, D.C., they're very centered around the engineering and manufacturing for these systems ultimately. And this whole messy biology, a lot of the engineers just don't like messy biology, period. Too unpredictable. But it does so much work for us, right? I mean, name what food you ate that wasn't biologically derived, or waste, that wasn't biologically processed. Biology just does a lot of work with it for us very efficiently. That's why we use it. So I think going back to your question on the hidden space community, is there are all of these parallels. Maybe it's not coalesced into, oh, these people are working on space settlement technology relevant things, like in wastewater treatment. They're trying to, how do you have a carbon negative wastewater treatment system? Those people are never engaged like with this from the space industry side, trying to solve those challenges. So there's all the genetic engineering of plants, or improvement of plants just generally. There's all these hidden kind of frontier sciences that just aren't coalesced around the challenges of space settlement, but they're very relevant to it. That I think if we brought all this together, there's be thousands of individuals and very exciting, relevant projects that some of those folks probably never think of how they're applicable to space settlement. And that story, that message there, I think is a little bit lost, but maybe we could get enough funding to do it. And I think it's a really low budget number. Again, this work is already being done. It's just not being probably coordinated in any relevance to space settlement. And it is an exciting, important work just for civilization here on Earth. And it's just, oh, okay, here's actually a market. Instead of it being this deep tech, instead of it being the scientist working on a project that's 30 years over the horizon, for some industry or some corporation, oh, here it is. Like, we could send this up to space in a couple of years because it's really relevant for that environment and economy. I think that is a relatively low budget item. I think that's somewhere between like $1 and $3 billion. And you could get a lot of this hardware truly to, regardless of what scale. Now we can manufacture things at incredibly small scale. So, to make a plastic distillation system, that's the size of a desktop printer, you can now do. Whereas 50 years ago, it would have been really hard to do something like that. So the scale of manufacturing, the technology is being developed to address these over the horizon challenges. We just have to kind of figure out what needs to go in the box. What do we bring with us?
That brings up one of the things I really want to focus on for this entire year. What is it going to take to make humanity multiplanetary? I don't think anyone has really asked that question in a way that's structured and targeted enough. We need to be looking at the entire scale of all of our companies that are building hardware, the organizations that are dealing with the public, and as a collective, because really there's no space industry. We have a terrestrial industry with some kind of space flair, but really we don't have an industry in space until we have major infrastructure. And that means we're all going to have, our usual market competition mindset that any company has to have, but also kind of an extra layer where we create cooperative models together so that we're building an entire industry, an entire civilization in space. What is it going to take to make us multiplanetary? If we're not asking that question, I don't think we're quite going to get there. So food is going to be a big part of that. I would love to see Congress perhaps incentivize some of these terrestrial companies, like food production, for instance, or plastics, or even clothing, to perhaps create some piece of what we need in space, and they'll get funding for this. That way, we're not having to spin up an entirely new industry or an entirely new company. You could just kind of take a piece of these different companies and dedicate that to what space needs, and they would still be able to derive, value in the terrestrial market. I think I would love to see that kind of strategy going forward. We're almost out of time, but I want to give the audience a little bit of time to ask questions. Do we have some ready?
Yes, we do. Daniel, this question goes out for Daniel. What plants are most important for life support, such as in an orbital habitat? So there are a couple of things that are like the musts, air and water, recycling, food protection, et cetera, et cetera.
I'm sorry, the first part of that question?
If you had to pick like the plants that are most important for life support on another planet, what are those orbital ones?
Interesting. What plants?
Yeah.
Okay. Oh, well, I got an interesting answer for that. So the pioneer plants, I work in big agricultural systems, and we try like everything to disrupt, weedy plants from growing in these really extreme, harsh environments. They are by composition the same as every other plant. So they're nitrogen, phosphorus, potassium, their elemental analysis are the same as a tomato plant. They're just a really efficient, resilient, weedy pioneer species. So for regolith extraction, I think we should send them out there, or for some step of the bioprocessing, we should have really resilient plants that we then harvest that biomass and kind of upcycle that through, let them do the work for us in extracting those elements and stuff for us.
Awesome. Great. And I think I can get one more in. This one's actually really interesting about, could a set of 3D printers to make greenhouses and other printers, plants to turn lunar dirt into soil, mining, refining equipment? It sounds like, can 3D printers help us out there in space?
I think I saw collectively be considered a von Neumann probe, if I'm looking at the same question there. Yes, I didn't know anything about von Neumann probes, but that's essentially biology. Biology is the only example of a true von Neumann probe where it's starting, with one machine essentially and reproducing itself. And I think bioplastic is very energetically cheap to make here on Earth. That's why it's rather cheap. And same thing on space. It's energetically pretty cheap to make, and biology as well. So I think if you were to send a von Neumann probe, I talked about the size of this, being scale agnostic. I think that would be a really interesting way of, you could send a really small system, and then if it's got carbon on site, you could really bootstrap this to a larger system, and actually make the hardware components. There's a researcher in Canada that's very interested in this that I'm working with, to actually try to solve in the 3D printing world, it's called the RipRap project. And it's, how do you have a 3D printer make another 3D printer? There's a couple more steps in there that you need that we're figuring out. But yeah, it seems very possible. Obviously, it is possible because biology does it. We just have to figure out how to do it at a larger scale.
I love it. That's the thing about space, is now it's just getting us to start thinking anything is possible, whether it's going to take a week, a year, a couple years, all that good stuff. So, well, thank you so much. Inara, did you want to add any closing remarks? We have another couple great guests that we have coming up this hour, but obviously what you guys just had with the coffee was great. And I think another thing we like to do is, if you want to put in the comments your contact information, so if someone wants to continue the conversation, they can reach out.
Yeah, absolutely. I'm so excited to be back here with Foundation for the Future, one of the organizations I think that's truly looking at a systems approach to how do we build the major infrastructure in space? How do we really create a civilization that's viable? So I'm excited to be here. You can find me on all the socials as Galaxis Gal, and I'm on LinkedIn as Inara Tabir. I'll put the link here in a moment. I want everybody in this community, whether you're in the industry or you're a fan, to start thinking about what it's going to take to make us multiplanetary. That's the question I think that's going to be huge this year. We need a wide focus of all the different pieces that we're missing, because we can't just build a rocket, go to space and hope for the best. we need to know what we don't know. And so that's what's going to come out of that question. So yeah, keep asking that question. What will it take to make us multiplanetary? And let's make it happen.
I love it. Well, thank you so much. Thank you, Andrew, Daniel, and of course, Inara. We really appreciate having you guys today to kick off our conversations for the future for this month. And I'm seeing everything in the LinkedIn profiles and the chat. So yes, everybody go in there. Let's make some new friends. Let's keep the conversations going.